Okay, so this is a recording of the slide deck we've put assembled for Chapter 5. We're going to be talking about some of the different components of what makes up a management information system. Okay, so we talked a bit about what is MIS, and things we talked about. There's obviously there's the people, there's the process, and then there's the technology. So what we're going to be talking about here is really the kind of what makes up what we call the MIS infrastructure. All right, so it's really it's how an organization, we can define this as how an organization will build, deploy, use, and share data processes and MIS assets. All right, so um, the, the elements. So when we talk about the stuff that the pieces that we use to assemble these types of things, really there's four. There's the hardware, all right, which are the physical devices. There's the software, which is the instructions that tell the hardware what to do. So, hardware without software is a doorstop. Software without hardware is a piece of paper. All right, so it's really a combination of these two that work together. All right. Data is what we kind of explored this, talked about it earlier. Data collected, measurements, facts, whatever that can be collected and analyzed in terms of context provided that used as a result, as we say here, can be used as a result of user behaviors and software and other things as well. So it's um, the key term around the whole idea is that we can collect larger and larger and larger amounts of data because we have so many new ways of generating it through handheld devices and phones and computers and systems and whatnot. And then the fourth piece, which is actually kind of the newer, I would say, of the four, this is kind of the newer piece, networking. So networking is the linking connectivity of one device to other devices through standard communication protocols. Historically, computer systems, the first systems, mainframes, were hardware, software, and data. Those have always been part and parcel of infrastructure, computer infrastructure. Network is a relatively, of the four, this is a relatively new, though highly important piece. Right. Through the 70s, what we saw was a lot of computer manufacturers really developed their own network. So what happens is IBM developed networking to talk to IBM equipment, and Digital developed networking capability to talk to digital equipment, and Apple developed communication protocols to work with Apple equipment. All right, but it was really the introduction or kind of the leverage, the movement towards the World Wide Web and the internet that developed a common platform. So the idea would be, you know, if you go back 20, 30, or about 30 years ago, if you go back 30 years ago, you know, every, everything had its own network protocol. So IBM had something called SNA and Apple had something called Apple Talk. The movement towards the internet, which uses a communication protocol called TCP/IP, basically standardized network communication. So everything talks TCP/IP now. Everything talks on the internet. The internet talks TCP/IP, and everything talking to the internet or using the internet talks TCP/IP. Right. So the idea of the person, or so the idea of as we look at this overall, how we assemble hardware, software, data, and networks in a kind of a multi-tiered um, arrangement. All right, so your lowest level here, your hardware and software. There's hardware and software really make up what we call the infrastructure. All right, which is your plumbing, connections, and boxes, and things of that, and software, databases, all the stuff that provides the fundamental grounding. All right, and then at the business level, we have business processes. All right, so business processes, we've talked about business processes, implemented through ERP system, defined by business, implemented through ERP systems and CRM systems and SCM systems. All right. And then, at the top tier, what we have here is business intelligence. So the idea is that, this provides the fundamental building blocks, the fundamental components are established in the infrastructure, implemented in the processes, and ultimately used in the business intelligence to answer questions and to make decisions and to drive activities. All right. So this role of an enterprise architect, is one in which really you you have there's a lot of terms on architect that get thrown around information technology. I like to think of an enterprise architect as someone who really spans all of these. So the idea is an enterprise architect will deal with the selection, deployment, operation, construction of the infrastructure, and then how it aligns with the business processes and how ultimately things operate around kind of generation of data to information to business intelligence to knowledge. So, the enterprise architect role is a multi-dimensional role that kind of spans everything on an end-to-end basis, dealing with both technical infrastructure, applications infrastructure, business infrastructure, security infrastructure, all of these different pieces, all kind of seeing it as a whole. So the idea of an MIS infrastructure, this represents a lot of times a pretty significant investment for an organization. This stuff is not cheap. I always like to cite, if you look at the richest people in the world, a lot of these people are, have their hands, Bill Gates, Larry Ellison, Hasso Plattner. I mean, these guys all have their hands, they were all software or computer systems and MIS infrastructure people. All right. So, there's obviously a lot of money to be made in this, and on a benefit side, there's actually significant benefits because, a well-deployed MIS infrastructure, can reduce costs, can make organizations more productive. You can optimize business operations and do also, a lot of very positive business things. However, simply buying infrastructure does not will not necessarily, you don't get this out of the box. You don't automatically, there's not an automatic connection between buying information technology or MIS infrastructure and deriving benefits. And quite frankly, you can spend, as always, if I'm very fond of saying, you can spend an astonishing amount of money in information technology, and at the end, really have nothing to show for it. So if it's not designed, if it's not deployed, if it's not used properly, it can actually, cause a business to fail or, impact overall value. So there's nothing automatic about, the value proposition of MIS. It has to be both, acquired, but then the implementation is every bit as important as the software, is just simply the acquisition itself. So some of the areas that we look at with this, kind of what we do with what we want to use or how we use MIS infrastructure. So the first thing we do is we support the basic operations. So we have, the basic keeping it running. So, keeping, capturing data, running the systems. The support operations include things like backup and recovery. So whatever all the information you're gathering, all the data you're gathering, all the systems, all of the stuff, the ability to back it up in case something was to happen to it. Right? It's data can be a very fragile thing. It doesn't take much to wipe it out. All right? So the idea of backing it up and recovering it, especially if an organization is dependent upon the functions of the system, backing up and recovering is primary. Plus, disaster recovery, in case it is quite possible you could lose the entire operation. And what's been happening is as organizations have leveraged more and more IT into their business processes, and basically the two have become very intertwined. When you turn your computers off, in a lot of ways you turn your business off. So this idea of disaster recovery, basically, which is really more of a technology kind of approach, but business continuity planning, which is really looking at the stuff from a business perspective, really is part and parcel of a critical piece of what we deal with when we're dealing with MIS infrastructure. The IDI. So one of the things we look at around the not just simply the functions of an application, but we call in software engineering, we call this the IDIs, what we call, or non-functional attributes. All right. Um, but there's these are the things that a software should provide the ability, or should have the qualities of. So accessibility, availability, maintainability, portability, scalability, usability, serviceability, recoverability. So all of these things are attributes, of what you want the MIS infrastructure to have. These are all the as they call non-functional attributes. So, functional attribute is, okay, I have an accounting system, it does accounting. That's the functional side of it. But all of these other things are, in one of the things that's interesting when we use the term non-functional attributes, um, the non kind of gives you, some people mistakenly look at that as, well, it's not as important as functional. Quite frankly, non-functional attributes are every bit as important as the functional attributes. Um, and if you don't have them, or if they are lacking in these, in the itchies as we call them, an application will, may not be successful. And then finally, this idea of, sustainability, support, you support operations, support change, but then support sustainability. So as we're seeing this evolution of technology, as things continue to evolve with MIS infrastructure, one of the big things that's been happening is infrastructure has moved from an internal, basically organizations would buy their own computers, set up their own operations, and run them internally. What we've been seeing is more and more of organization of kind of outside organizations, cloud computing, virtualization. Virtualization is where you take physical hardware and basically be able to run it as a software program. So the idea of a virtual machine is a computer that runs inside of another computer. And as systems have gotten larger and more powerful, you can basically run hundreds and thousands of machines inside of one machine. So you have one large hardware server which can actually support hundreds and thousands of virtual machines, which really are just basically computers. It's basically computers. Extending that out to what we call cloud computing. We'll be talking a bit more about cloud computing as we're moving ahead. But cloud computing becomes a combination of taking virtualization, the ability of creating virtual machines and accessing and using virtual resources, combining it with the internet, and giving you the ability to access, allocate resources, or systems and servers and technology and storage, across the internet. And so there's a couple big providers. It's one of the big rapidly developing areas in IT these days. Biggest provider out there right now is Amazon, something they've called Amazon Web Services. So these kind of evolution from grid computing, which is like kind of combinations of lots of small computers all chained together, into through virtualization through into what we're calling cloud computing now, is really kind of the longer term sustainable vision of where this stuff is going. So we talked around BCP just briefly. Just want to touch upon this. So BCP is business continuity planning. It's a business preparedness plan. How does the company recover? So it's less technical. It works in concert with a disaster recovery plan. So that, sometimes these terms get used interchangeably. I like to think of business continuity as more in terms of on the business side, and aligns with a DR plan, which tends to be a little bit more on the technical side. So as we say here, it's a science-determined business impact analysis versus the money an organization is willing to spend. This is insurance, and a lot of times, organizations can simply buy and duplicate, all of their infrastructure, and so you have 2 or 3 or 4 versions of it, but that is not necessarily the most cost effective. Assuming that an organization cannot afford to, continuously replicate or redundantize every component in their infrastructure, there's a planning process that has to be involved around what is the what are the core processes that run the business, and then what is and from a timing perspective, how quickly do they have to be restored back online. So the questions some of the questions we look at here around kind of working on BCP. What's the frequency of backup? The time to recovery. Do you use hot, warm, cold site? Do you are you is your business of such a type that you can never afford to go down? So the ability to architect a highly available system, which can be more expensive than just simply having some spares around. Um, so backup recovery is a part of BCP. Deciding kind of what happens on the business side is you know an equal carries equal weight. This is really the essence of this stuff is really risk management. So understanding the key things as we look at from an analysis perspective around BCP is what is the what's the probability, what you're measuring impact versus probability. What is the probability of an event will occur, and then should that event occur, what is the what would be the impact. So the idea is you want to look at you know um, high probability, high impact is the areas you want to put a big focus on, and the other ones as we go. So you can't, assuming not all things are equal. So it's kind of our chart here. The optimal point is kind of a balance between the cost to the organization of loss of capability versus the cost of the redundant recovery infrastructure, the cost to recover from a disaster. So that point here is something and this is a business decision. So this is the emphasis. The key word when we look at BCP is it's business continuity. So it's not necessarily technology. This becomes a big. The people making these decisions need to be the business decision makers. We talk around this idea of an agile MIS infrastructure. Around these different attributes: accessibility, availability, reliability. Traditionally, MIS infrastructure has not necessarily been the most flexible. As a matter of fact, up until about maybe 15 years ago, the implementation you would, for example, an example of like mainframe environments, organizations would have one mainframe. If you ran out of capacity on that mainframe, you had to buy another mainframe, or your ability to scale that and be adaptable with it was pretty limited. And actually was one of the big challenges in terms of MIS and IT organizations being able to um, meet business needs and meet business requirements. So this idea of an agile, these are the attributes you want to have. So you want to be the control over the accessibility, availability, maintainability, scalability, usability. So um, these are all different attributes, and we see a lot of this stuff begin to be reflected in things like uh, virtualization of, of, of infrastructure, of MIS infrastructure, and deployment of cloud systems. For example, a cloud application, a cloud system, you can add resources or take away resources to meet requirements. So, say, for example, if an organization, for example, Netflix, which runs on AWS, um, Friday night they will add more horsepower into their infrastructure. They will add more systems to meet a demand on Friday night versus perhaps 2 o'clock Monday morning, and then you can adjust it up and down as opposed to having to pre-buy everything and basically buy infrastructure to your maximum point of utilization. So this idea of an agile is something that is becoming um, is something where MIS infrastructure has been evolving and continues to evolve. So we're seeing this idea of what we'll call things like a hybrid structure, where you'll have combinations of physical infrastructure, virtual infrastructure, cloud infrastructure combined together to provide your overall MIS infrastructure. So this is a couple charts here of kind of a little bit of interest here. So this is our first model here. It gives you kind of a relative visual. It gives you a visualization of kind of the relative um deployment or utilization of different types of IT infrastructure. So traditional, So traditional would be PC. So this big blue blob we see here is kind of the percentage of, kind of the dominance of the PC. So I mean, you say, well, how did Microsoft get to be so big? Well, if you kind of follow this chart here from about 81, kind of the introduction of the IBM PC was in the 81 timeframe. They've actually maintained a pretty significant, um, it's kind of plateaued a bit, but they've still maintained a pretty strong positioning. Some of the other ones we see, like Apple, this is kind of the Macintosh, which was introduced in like the 80, 83, 85 time frame. Um, some some of these other ones are actually more kind of legacy. So as you see, as we kind of move forward here, like the iPhone and the Android, which are going to be up here, really um, did not really show up until like 2000, the latter part of 2007, 8, 9, 10 timeframe. So they're relatively new. A lot of these other ones you'll see back here are back in this space. One of the ones that's interesting is Commodore. So Commodore was actually, um, I would describe it as the first home PC. Basically, it was an 8-bit. Commodore 64 could be used to play games and could do some simple computing stuff, but it was about a $200 computer that you could plug onto your TV. And you'll see here that they actually had a pretty decent run here for a number of years, all through the 80s, and ultimately kind of phasing out as it got into the early 90s. But and some of these are clearly older technologies as we look here, kind of first generation. The Atari ST, Atari 400, Commodore, Amiga were all TRS-80. Really, were all kind of your kind of very early first generation kind of home computers. Other chart here is a kind of a breakdown of what are the current breakdowns of the types of platforms are out there. So platforms being hardware, software, combinations of hardware and software that you run systems on. Right? So this is a so this this as we see here, kind of pretty significant impact of Android. Apple is kind of carving into the Windows space. As we see BlackBerry kind of having its high watermark in the 2000s, but kind of really fading out as we've gotten into the teens here. And then there's still obviously in other, so the major platform Windows, even if its space is eroded a bit, but still seems to have has a pretty good position. Android is, as you can see here, significantly pretty from a market share actually is above Apple. And one of the things what um, from a business strategy, what Google did when they developed Android was the idea of their business model is driven by eyeballs. So the more people they can get to log on to Google and use Google and look at advertisements on Google, the more, the better, that drives their potential revenue. So the idea is, for them, it made sense to develop an operating system, Android, and then give it away versus Apple, which is, basically sells the hardware and the software together in one integrated platform. So this is kind of how things are shaping today. We'll see how these things will continue to shift as we continue to move forward. So the idea of a sustainable MIS is, this right here is a chart of really what Intel um, processors, the number of transistors that are in an Intel processor. All right, so as you can kind of see, going back into like the 70s, you can see 1,000 transistors, or 4,004 or 1,000 transistors, 1,200 transistors in a 4004 chip, which is a early 70s Intel processor. As we scroll up here, you start seeing the growth as we've gotten up to, as we got into, say, for example, the early 2000s. It was a 10 million transistors. And the curve continues to, move upwards. All right, so we're looking, in 2015, and obviously we're a couple years beyond 2015. Sandy Bridge is that a billion? Could be. I'm not sure. I'm not sure after we get to a certain number of zeros, I start losing track myself. But anyway, it's a lot of transistors. All right, but this has been this has really been the past. When we talk about Moore's law, this is kind of the representation of what Moore's law actually means in terms of, and the idea of the power of a processor, computing processor, is really driven by the number of transistors. All right, so this gives you an idea of what these horsepower, kind of the horsepower of these um, compute engines can do. So the idea when we talk around like cloud computing and virtual computing, being able to run thousands of machines inside of a virtual machines inside of a machine. This is the type of horsepower that enables you to do things like that. All right. So, um, so the challenge we run into is, the disposability. One of Intel's model is that, they made the computer, or the processor with their, as they've released this, um, they made it basically disposable asset. So it's like every 2 years, as things go along, as software develops, as more capability gets built in, basically moves this stuff along. So one of the things we've run into, a couple things. Number one is the power consumption on chips um, was actually was very significant. As a matter of fact, as we got into this space up here, which would be in in the 2000 through 2010 time frame, is the compute, the power draw on chips got to the point where there was significant questions of whether or not they would continue to sustain this model, this Moore's law model around the capacity transistors capacity. Actually, there were some significant alterations in chip design with basically creating multiple cores into a single machine, which drew less power, which has really enabled us to kind of extend this curve a little bit longer. But irregardless, significant. The amount of energy that computers draw is actually pretty significant. Plus, also, the idea of the disposability of PCs. I mean, people think, well, just kind of, when you make a PC a disposable asset, you kind of toss it away. The problem is, though, the content of those, in terms of like the battery, in terms of the electronics, are such a trying to. It's not as simple as just simply throwing away. It's not particularly it's not environmentally friendly. Right? So this idea of, you know, how do we dispose of this stuff as we move stuff along? So this idea of sustainable, MIS is about minimizing the damage that technology, the potential damage, energy or technology can have on the environment. So, this is about, part of an overall, corporate social responsibility of, being able to focus on e-waste, energy consumption, carbon emissions. This is all, when companies talk around having a sustainable MIS is also, architecting their MIS infrastructure so that it takes these factors into consideration. So we talk about this idea of a sustainable MIS, kind of data centers, this evolution of data centers. Um, Data centers used to be internal organizations. Every company had their own data center, or maybe they had more than one data centers where they would store all your computers. Now we're seeing more and more of external data centers. So combining recomputing, which is um, you know cord the coordination of multiple systems across the network. This idea of, as we talked about, virtualizations, multiple machines on a single device at the same time, or cloud computing, which is utility computing. All of these have advantages, or kind of lend itself towards um, providing the ability to have sustainable MIS. A lot of like cloud providers like AWS, like Amazon, or um, Microsoft, which has a cloud solution called Azure, will put their data centers next to or close by a energy source, like for example hydroelectric, um, energy sources, because number one is data centers. These data centers still have a tremendous energy draw, but being able to put them near um, put them near an energy source, an affordable and uh, reusable or alternative energy sources is actually one of the big things that they're focused on. I know Google, one of the experimental things Google has been looking at is actually having an offshore data center that would harness the power of the waves to be converted into electricity to drive data centers. So this is all stuff that's in development and kind of being experimented and looked at. But this is a reality. So this idea of cloud computing is very much a reality in terms of how organizations are approaching its utilization of their and deployment of their MIS platforms. So we talked just a little bit more about cloud computing. So really has been around. Amazon is the significant player in this. They actually came online in like the mid 2000s with this idea of providing computing power as a service. So instead of going out and buying a computer, you connect onto their their um, their AWS site. It's a website, and you can access and run computers, hundreds and thousands of computers. Um, large, give me an idea of the power of this and kind of the scale of this. Uh, Netflix is actually uses for uh, all of its video distribution infrastructure is actually running on Amazon. So it gives you an idea. That's a pretty big, pretty significant operation. So rather than running, on a local server, the idea is you can run this stuff on a cloud. So you don't really, it's not physical infrastructure anymore. It's networked virtual infrastructure accessed across the internet. So there's a couple different um, implementations of ways we look at we kind of construct clouds, and basically it's kind of what you're buying. So this first one is what we call infrastructure as a service, or IaaS. So what that basically is, it's hardware and networking. All right. So basically you're buying access to a virtual machine of different sizes with different networking capability. And then on that, company will install whatever application softwares or that would be uh, desired. So this is compared against what we call software as a service. So the idea of software as a service is you really don't see any of the infrastructure. You don't see the net service. You don't see the servers. You don't see the network. You really are just accessing an application across the internet. You pay per view. Excuse me. You pay per use. Um, based upon your utilization on both the infrastructure service and software as a service. You pay on you pay per utilization on like a tolling model. So you can, add resources and take away resources and only pay for what you use. Um, so, some significant advantages of the SaaS around simplification. Organizations don't have to maintain, acquire and maintain their own operations. They can, move that outside. So this has been a both infrastructure service, software service have really been the two mainstream cloud platforms that are out there. All right, so software as a service, best example of that would be Salesforce.com, which is we talked about that earlier about a CRM application that runs as a delivered software as a service. And actually, a large portion of their growth and what they've been able to do has been because they are a cloud-based delivery system. Organizations don't have to buy all and run all of the supporting infrastructure. And then the third one, which is not quite as well deployed as infrastructure or software as a service, platform as a service. So basically, I would describe it as infrastructure as a service plus a bunch of tools that you can write your own applications. So instead of with infrastructure as a service, you have the hardware, you have the operating system, you have the network. You add your own tools, you add your own software. Um, Platform as a service, you get everything IaaS does, but it also you add it'll actually give you things like databases or integration tools or networking tools or things of that nature. One of the advantages, and they're like with Amazon, one of the big advantages for from the vendor perspective is that if an organization was to come on and develop their applications using the tools provided by platform as a service, basically that kind of locks them in because that is those are proprietary tools. They only run on that particular cloud platform. So you'll see a lot of times with AWS is they've been doing a lot of work around kind of offering um, quote unquote free tools with the idea of okay, if you develop your applications and run it using these tools, then basically you'll be staying. All right. So the other characteristics. So it's the three core: infrastructure as a service, software as a service, platform as a service are the three. All right. But the implementation of these things, of how they are implemented. So there's technically there are four, but we're really usually there are only three that are of well known. Um, so what we call public clouds, right? So basically Amazon Web Services and Azure are examples of public clouds, which is you can get access to them across the internet, offsite. Basically offsite stuff is stored offsite or run offsite for a location, and you can run any of these types of applications on those over across a public internet. A private cloud is really an organization where an organization will take its existing infrastructure and run it as its own internal cloud. So it'll have the same characteristics of flexibility, expanding and contracting, being able to dynamically allocate resources, but it'll do everything in house. All right. So a lot of times you'll see, one of the primary reasons cited around this stuff is for security reasons. Organizations will be under some regulatory requirement that they must run it under their own infrastructure. So you'll see things like private cloud. There's been much more utilization of public cloud than private cloud. All right, but private cloud is still out there. Organizations are going, and then there's this third model, which is still kind of an this is uh, another ongoing developing kind of technology, what we call hybrid clouds, where you take a mixture of public and private cloud offerings. So you're seeing this is probably so public has been really been the key driver on cloud. So usually a lot of times when we talk around what is a cloud, we're usually talking about public cloud. Hybrid cloud is basically taking a combination of a public cloud resources, combining them with private cloud, and basically making it as a seamless whole across across the boundaries across private and public. Still very much in development, so things are moving along with it. So one expectation, in the future, we may see more and more of like these hybrid types of models. But this is, still a lot of development. This is cloud computing is still, even though it's pretty significant right now, it's still relatively early in its kind of where it could go. Right? So, and that is really it for chapter 5.